Hello one and all, and welcome to the Math Magic Show. In this one we're going to find the following limits. So the limit, as for example n approaches 0 from the right, of the following expression: 1 plus n over 1 minus n raised to the 1 over n. Now first we have to recognize whether there's a problem or not. So is there a problem with this? Well, there is, because if you try to plug 0 in there, you would end up with the following. So pretend for a second that you're going to just plug 0 into the expression. So you would have 1 plus 0, which is 1, that's okay. And the bottom you would have 1 minus 0, which is 1, that's okay. 1 divided by 1 is 1. So that would be okay, that would just give you a 1. But then in the top you would have 1 over 0. You would have this, 1 over 0. So in other words, you would end up with some kind of weird thing that says 1 raised to dne. 1 raised to does not exist. Whenever we encounter some kind of like a weird thing like that, we have to usually involve exponentials and L'Hopital and so on. To make this work, the next key step would be to recognize that if you have a function f of n, so in our case f of n would be like the 1 plus n over 1 minus n raised to the 1 over n. You can write this equivalently as e to the ln of f of n. That is so because the e and the ln functions are inverses, so you could cancel them back off and get back down to f of n, you see? But being able to rewrite it as e to the ln of f of n is very useful, because then the limit becomes easier to take. So let's work that next. I'm going to say the following. I'm going to write my function as the limit as n approaches 0 from the right side of e to the ln of 1 plus n over 1 minus n raised to the 1 over n. Next, I'm going to start applying basic log rules, which states that when you have something in the exponent up here, you can place that in front of the logarithm. That's a power rule for logs. So I'm going to have the limit as n approaches 0 from the right of e to the 1 over n, and then ln of 1 plus n over 1 minus n. So that's pretty good. And now there's still an issue, and the issue is this one. Take a look. That 1 over n that you see right here, because it's 1 over n multiplying the ln, the n from 1 over n could be put under the whole thing to make it a bit more clear, okay? So in other words, I'm going to write this now as the limit as n approaches positive 0 rather from the right of e to the ln of 1 plus n over 1 minus n, and the whole thing is over n. So now let's see what happens if I replace n with 0. Okay, there will be a very specific consequence, so pretend for a second that I am going to let n have the value 0. So I would have ln of 1 plus 0 over 1 minus 0 over 0. So if you work this out, think about it, it's going to give you now ln of 1 over 1, which is ln of 1 over 0, but of course ln of 1 is 0. So this ends up being 0 over 0, some kind of not defined again quantity. So that tells us we got to hit this exponential there with L'Hopital. So I'm going to separate my work so everything stays clean, hopefully. And also another thing that we can do, because we are dealing with the e function, we can slip the limit into the top, into the exponent, and it's equivalent to what we have here at the last line on the bottom, okay? So in other words, I can rewrite this as e, and the limit as n approaches 0 from the right. Remember, there's a rule that says that, for example, the limit of a function means that you can just slip the limit, for example, into the function itself. So that's what I'm doing here, okay? In the top I have this exponent, which I'm kind of imagining is essentially almost like a separate function. So I can slip the limit into the top, and then it's going to become e raised to the limit of that expression. For that reason, next I'm going to say the following: ln of 1 plus n over 1 minus n, and then over n. Now we have to do L'Hopital on the expression in the top because of this step back here, remember, where it was 0 over 0. So let's work that out. I'm going to have to do a lot of derivatives here. So first of all, you differentiate the top and the bottom individually, not using the quotient rule. So the derivative with respect to n of the n in the bottom, meaning this part right here, that's easy. That's just equal to 1. Okay, that's done. Nice. But then the second part would be to find separately the derivative of that expression in the top. Now that will require us to use a whole bunch of different things. So let's take a look. The derivative here of ln of 1 plus n over 1 minus n. So I'm going to have the following. Take a look. Now I've got to use a chain rule because I have ln and I have a function inside the parentheses on top of it. So to find this, I'm going to have to use a chain rule. I'm going to have to write it down this way because it's going to get fairly extensive. So you're going to differentiate using the ln rules, which is first going to tell you that this is 1 over 1 plus n over 1 minus n. So it's the ln rule that says it's 1 over the quantity within the parentheses. It doesn't matter how complex this quantity is, the rule is the same. So it's 1 over whatever that quantity is, okay? And then you're going to multiply by the derivative, so with respect to n, of this quantity here. That would be 1 plus n over 1 minus n. So to do that, you can use either the quotient rule or you can use, for example, the product rule. Either one will work. So I need to do that piece separately before I do anything else. Okay, so this is separate work, and I'm just finding the derivative of the following: 1 plus n over 1 minus n. And I like to always just stick to the simplest rules I can find and the least amount that I have to memorize. So for that reason, I'm going to do it this way. I'm going to rewrite this as 1 plus n multiplying 1 minus n to the negative first. Then I can just use the product rule and I don't have to memorize the quotient rule. So for that reason, I'm going to have the following now. That states you're going to have to first differentiate that piece, 1 plus n. So the derivative of that with respect to n is 1. Then you copy the 1 minus n to the negative first, and then you add to it the derivative. So then I'm going to multiply this by the derivative of 1 minus n to the negative first. So when I do that, it's going to give me negative 1 down. So I'm bringing the exponent down, and then 1 minus n to the negative second. And then you have to multiply it by negative 1, because then you have to use on this term right here, 1 minus n. You have to use the chain rule because there's a negative n inside. So that becomes then negative 1 again on the outside in this position right here. So now we just need to clean this up a little bit. So for the first time, it's going to have 1 over 1 minus n to the positive first. Remember, once it goes back bottom, right, then this becomes a positive quantity. And now for the second piece, it's negative 1 times negative 1, which is positive 1 times 1 plus n, which is then just positive 1 plus n. So over here, I'm going to put plus 1 plus n. But then in the bottom, remember, I'm just rewriting this piece. We had 1 minus n to the negative second. So that's got to go back down as 1 minus n to the positive second. Good. So now we have to clean this up. So in the first term over here, you're missing 1 minus n. So this is 1 minus n to the first. This is 1 minus n squared. So you need to multiply the first one by 1 minus n over 1 minus n, which is really, again, just a form of the number 1. So for that reason, I'm going to rewrite the first term as 1 minus n over 1 minus n squared. Plus 1 plus n over 1 minus n squared. And then I have to now the bottoms are the same, so I can write that one time as 1 minus n squared. And then here in the top, it's going to be now the following. Let's go through this slowly. It's going to be 1 minus n plus 1 plus n. So then you cancel off what you can. So see, this cancels with this, and then 1 plus 1 is 2. Okay, so that's going to give us finally 2 over 1 minus n, and the whole thing is squared. Oh boy, okay. Progress. Let me zoom out a tiny amount. Okay, I've zoomed out here so that you can hopefully see things better, and let's finish this up now. So let's go back to the middle. I'm going to have e and the limit as n approaches 0 from the right. I've differentiated the top. Now let's be very clear, because what we have is the following. You still have this part of it. 1 over 1 plus n divided by 1 minus n. So where's that coming from? Just to remind you, that's coming from right here. Okay? And then this piece, well, that's just 2 times 1 minus n squared from the quotient or product rule. So that's got to be stuck in there next to it. So I'm going to have now the following. Let's be very careful here. Times 2 over 1 minus n squared. And then at the next point, I'm going to take this expression and just flip it. So it's going to become e, the limit, as n goes to positive infinity, of 1 minus n over 1 plus n times 2 over 1 minus n, and then the whole thing is squared. Now at this point, you see there's a common factor that you can cancel off. So specifically, what I mean is you can cancel this and then this. So that's going to leave you now with the following at the last step. E and the limit as n approaches 0 from the right. And then it's going to be now 2 over 1 plus n multiplying 1 minus n. So lastly, I observed that now here I have n in the bottom in this position and this position. That means I can just plug 0 directly into the bottoms there, and there are no more issues like division by 0 or anything like that. So I will have e 2 over 1 plus 0 times 1 minus 0, which is just e to the second, and then this here is the value of the limit. Done very rigorously, step by step, just for fun, just so we can review a lot of different rules. Thank you so much for watching. I hope it's been helpful. Please leave a like and subscribe. I'll see you in another video.